In this video, we cover why you should consider doing a boost report to improve the quality of your project. So why should you boost your project? EMU has been specializing in passive house building science for the last 15 years. However, 4 out of 5 projects going for the boost with EMU don't actually pursue passive house building certification. We use the passive house science as a handrail for teams to make informed decisions for the important matters of their project, such as, do I need X in my climate? Is product A better than B for my project? How much is enough and how much is too much? So these are the questions that we try to answer, and we do answer in doing the boost for projects. Boosting with EMU because we used to be architects, so we are very familiar with what decisions project teams need to make at different stages of development of their project. And we have experience in different countries, including Australia, Italy, and all over the US for passive house projects. That makes us familiar with different climate zones, from hot and humid to very cold and dry, to very high elevations too in the mountains. And we are familiar with domestic and international products. I am personally from Italy, and we practiced architecture and passive house in Europe for about 8 years before moving to the US. So we are very familiar with whatever is coming from overseas. And we regularly train passive house builders, so we are very familiar with what questions come up, what is easier to implement in a project versus not, what products are more user-friendly, what applications are going to be easier to do on site so that you can get that quality. When and how to boost? Boosting is best done at the early stage of a project, typically at the schematic design, so at the SD stage of a project. We try to answer, and we do answer questions including, what is the sweet spot for insulation? What kind of R values are the best spot for your building assemblies, for your exterior walls, for your ceiling, for your floor or slab? What kind of window package do I need to get comfort, depending on your climate, of course? What kind of optimization can I get to find the sweet spot between solar gains in wintertime and shading and solar protection in summertime? How do I get indoor air quality? How do I get there via fresh air supply? What kind of filtration system do I need? What kind of ventilation concept do I need to get indoor air quality? As well as, if I insulate more, if I use such high performance windows and doors, if I use shading or high against glass, what are the heating and cooling loads resulting from that? So what kind of mechanical system do I need for my project? So this is what we designed as part of the EMU Passive Design Build Boost report. This is a report that we designed as architects to provide answers that are very crucial to make decisions in terms of budget, in terms of design overall, and in terms of what kind of products to pursue for your project-specific needs. We provide you with a good, better, best set of scenarios, including what kind of R values we recommend for your walls, for your floor, for your ceiling, what kind of performance we recommend for your windows and exterior doors, what kind of fresh air ventilation system do we recommend for your project to get indoor air quality. This specifically includes, we specify the airflow rates for each individual room inside the building so that you do get that indoor air quality. And lastly, we provide also the heating and cooling loads for your building so that you don't end up with an oversized mechanical system. Boosting, we're seeing it can pay for itself. This is an extract from a larger study that you can find on our YouTube channel. If you look in our YouTube channel, and there's also a link in the description below, we are publishing right now a set of videos covering the EMU report on building standards. And as part of that standard, if you look at the playlist and find embodied carbon and resource efficiency, for resource efficiency, this is what we're talking about here. We took about 50 projects pursuing a performance-based approach, that is PHI, low energy building, and compared that to the FUSE core prescriptive approach. Long story short, we compared a prescriptive approach that you may find online, that is FUSE prescriptive, and we compared that to a performance-based approach. And we found that over 50 projects, for about 20% of them, 20% of those, for about 20 of those projects, the prescriptive and performance-based approach would get a similar energy performance for heating and cooling, but the performance-based approach would need about 800 cubic feet less insulation, because we can optimize other things such as the low E-coating on the glass. We can tweak it up and down to optimize it for summer and winter performance. So in other words, you can get to a similar performance or better typically, but you will need less insulation, so less construction cost, if you're using a performance-based approach, which is basically what is at the base of the EMU Boost. If you save 800 cubic feet of insulation, you can save a lot of money. And what we found is that even when we included the cost of the boosts that we charge the client for those projects that were using the performance-based approach were actually saving about $5,000 compared to the prescriptive approach projects to get to a similar energy performance. So the next step, how to start your boost, you can go to our website and submit a form. And just this basically comes to our inbox, and we will follow up with you. And I would like to chat more about your project and see what your goals are.